So we're starting chapter 6. We're starting applications of integration, right? So this is oops, sorry, I want to add a section here. Chapter 6 overview. So my goal today is to get 6.1 done, and we will. It's easy. It's very simple. And then we'll start 6.2, which is quite difficult. Okay, 6.2 and 6.3 are difficult. 6.4 is kind of complicated, but we have some parametric equations to do. Anybody remember doing parametric equations in pre-cal? Y equals r sine theta, x equals r cos theta, that type of thing. So you have a third parameter in there besides the x and y. You should all remember x equals r cos theta. So even if you don't, I know you learned it. So we have some parametric equations to do today. So maybe we'll only do 6.1 today. But chapter 6 is all about integral applications. And so, of course, we know that in general, the integral gives us the area under the curve. All right? But it turns out that area could be many things. It could be a force in physics. Okay. It could be a volume in biology, a volume of bacteria. It could be a probability for computer scientists. Okay, so it's kind of fascinating how we have found this connection to integrals and things that we do in our actual field of study. But it makes sense that the integral is adding things up, right? So certainly you could imagine adding up, the amount of force it takes to move something from here to here, and then the force from there to there, right? So in terms of that, it's pretty easy to imagine integral working. The sum of the bacteria, the volume of the bacteria after time t, and then after time 1, and after, you know what I mean? That makes sense too. Probability 1 is a little bit weird, but you can imagine the whole area being 100%, and then some portion of the area being your numerator to get a probability, right? So not that far-fetched, but there's some beautiful ones. But 6.1 we're talking about really that area, right? And 6.2 and area between curves. Or with parametric functions. Parametric functions, they're easy, so don't stress about that. 6.2 is I'm going to create volumes. So I'm going to take an area and rotate it around an axis and create a three-dimensional solid, right? So this is volumes, and we have two methods there, a disk method and washer method. In 6.3, we have volumes by the shell method. In 6.4, we have arc length and surface area. Certainly, you can see an application of surface area to engineering, right? The length of an arc, right? So and then 6.5 is centroids. So that's really a physics application, physics and engineering. But I'm not going to do centroids. And then 6.6 is the physics applications. And that's a project if you're a physics major or an engineer that's not a bioengineer, right? So all the engineers that are not bioengineers. 6-7 is bio. I might have these wrong. Uh, 6-7 is also finance. Believe it or not, there's applications of integrals that are used in money. And then 6-8 is the probability. So the math majors will do that one. Surely you have computer science and math majors are doing that one. So this is my my physics majors are doing this one, physics, and non-bioengineers. The bio is the bio majors and bioengineers. And probability is math and computer science. And I think that's everybody. Am I right? Did I miss anyone? If you're doing do I have anyone doing biochem? No, right? So if I say if you're doing biochem, you should also do the bio applications. But I got everybody there, correct? And that should be an easy 10 points on your grade. It's just a section of WebAssign. You really can do it. You probably can do it already, because it's just taking the methods we did in Chapter 5 and applying them to your fields. So you probably can start them already. You don't have to turn anything in. Right? So it's just a little independent study that hopefully you're inspired by because of it's related to your fields. And I know the tests are tough, so I like to have a way for you to, make up for it a little bit. If you do all of the homework and the project and your extra credit, you've got 25 points already. So a 65 would give you an A in the class. A 65 average would give you an A in the class. So you can get D's on your test and still get an A in the class. And I've done this on purpose. I know the tests are difficult. So keep that in mind. I still would like you to get, I'd like you to get 80s or higher on the test. And I think you can, but you have to study, and you can't, and I know I'm rambling on and I'm recording, but you gotta study, you gotta practice, you gotta make mistakes. You can't just say, I get it. It just doesn't work that way. Some things in life have for us. And so, like middle school was pretty easy for most of us, right? High school, I did nothing. I passed high school. I have no idea how I passed high school. I don't want to tell you what I was really doing in high school because I'm recording and I don't want to get fired. But, it's different now. And it's usually a Calc 1 or a Calc 2. For some students in math, it's even pre-Cal, where it's like, oh my God, what the hell happened? All of a sudden, this is difficult, right? But it's usually Calc 2 is the real, that one where it goes, what? What the hell happened? Okay. So I might have these things wrong in terms of my number here, physics, bio, probability. But look for those titles and pick the one you want to do. And you don't have to do the other ones, okay? Don't do the other ones. They're all 4 questions. All 3 of the projects are 4 questions. And they're about 2 and 2. So like the physics are 2 questions on the force for the spring, right? And then 2 questions on work. How much work does it, what's the force needed to push something up a hill, kind of thing. So there's our Chapter 6 outline. Let's start in 6.1. So we already know from Calc 1, right, we already know that if we're doing the integral from a to b, right, of f prime of x, we get f of b minus f of a, right, which gives us the area under the curve. Right, pretty simple, yes? And how we got that area was using rectangles, right? In fact, n rectangles, n partitions, and then letting that limit go all the way to infinity. So we would draw that rectangle. So for example, I have a right-hand rectangle here, right? And I would say, okay, my area is approximately equal to the sum from I equals 1 to n of those rectangles, right? And I got the base from delta x, and I got the height from f, the derivative, right? Now, why am I using a derivative there? The book doesn't. But you know that when you take the integral of the derivative, you get back to the function. So I'm just using that notation. It's a little different than what the book does. But we got the exact area in Calc 1 when we did the limit as n goes to infinity. And what happened to the sigma notation? What did that s turn into? What did this symbol turn into?
The integral?
The integral symbol, which is an s. So you can see it as a sum, right? So that sigma is a finite sum, and the integral is the infinite sum. And so we're going to sum from a to b. We're keeping that derivative f prime of x, but what happens to delta x? What happens to delta x when I do an infinite number of rectangles? What does delta x become?
It approaches 0, becomes infinitely small.
Good. And what symbol do we use for an infinitesimal? Well, what's missing from my integral? How's that? Look at my integral. What am I missing? Dx, exactly. So that as delta x becomes infinitely small, it turns into dx, right? Which is that, like, so tiny that you can't even see that anything is there, right? And so this is Calc 1 that we're talking about here, right? So now how are we going to move this into Calc 2 is we're going to have two different functions, and we're going to get the area between them. Okay, so this is very, very easy. But are we understanding here that we're going to get a rectangle? We're going to get a bunch of rectangles, right? And right, you can picture the whole thing. Let's say I have 4 rectangles there, right? And I get an approximation for the sum. But as I increase the number of rectangles, I get the exact area. And so we're going to be doing that. We're going to be seeing a bunch of things in this chapter move from the sigma notation, the sum of areas of rectangles, into integrals, right? And so the process is the same. For the rectangle, I need a base of the rectangle, which is always going to be my delta x, or now my delta y, you'll see later. And for the height of the rectangle, it's got to be a function of x or a function of y, right? So it's going to be that plain old vertical piece that we're used to for the height of the rectangle, or it could be a horizontal piece now. But the key is that I'm going to be creating formulas like this, and then we're going to turn them into integrals, right? I'm going to be creating sums of areas, and then we're going to, just kind of let that limit go to infinity. And we should understand that the function is staying the function. The width of the rectangle goes to dx, and the summation goes to the integral. And then other pieces will kind of fall into place. So more generality first before we do a couple problems. So I want to just go to my next page, area between curves here. So there's a couple of themes that are going to carry through Chapter 6 work. Look at a chat here, sorry. Oh, nice. Ashley set up, so we set up a study session for today at 3 p.m. And Ashley, that is to everyone, right? Is that correct?
Yeah, it's in the Discord. We talked about it a little bit to see when some people were available for today, and we chose 3.
Beautiful. I love it. Thank you. I had said yesterday, and I think I had said it in Calc 1 too, just in case you don't remember, but for me, the study groups were really key. It was so easy to say to a peer of mine, what the hell is that teacher talking about? They're crazy, right? Or did anyone get this problem? Show me what you do, and then and then showing someone else how to do something really gets it cemented to you. So don't feel like asking questions helps other people as well. That's really key. And then when I went to university, everybody basically failed every class. So they curved. So everyone knows they curve. So no one would help each other, because if I help you get an A, maybe I don't get the A. Right? If I help you get an A, I don't get the A. So so my study group would say, hey, let's all of us get the A's. Right? So we helped each other and really worked on things, and that made university a lot better, a lot easier, and it was tough, right? So not that the material is different. The material is the same. If you took Calc 2 anywhere, you'd have the same material, but you could easily get lost. I doubt at a university with 150 students in it, the teacher's saying, I'll make a one-on-one appointment with every one of you for an hour every week. I doubt it. Okay. My shrink just called me, so I might have to take a phone call. I don't know. Maybe he's having a panic attack instead of me for once. Oh, yeah, I'm recording this. Don't use that against me. Okay, area between curves. I've got 2 functions that are crossing at A and B. And I'm interested in the area between the 2 curves. Give me a second. I got to take a phone call. Dr. Isaac, I'm in class. I'm sorry. I thought it was clear. I'm in class for the next 6 weeks. Okay, no problem. He said, my doctor said, no problem. That'll be $250. Okay, so I want the area between curves here. And I'm going to say here my upper function is f and my lower function is g. And in this particular case, I want to draw the rectangle, right? I want to draw the rectangle bounded between my 2 functions. So there's one of the many rectangles that I'm adding up to get the area, right? Is that clear? So I guess if I had to draw them all, kind of thing, right? So that particular area, right, is the sum of I equals 1 to n of, in this case, my delta x is still delta x, right? So you can see where the base of my rectangle is. That's a delta x there. But my height of my rectangle now is a top half of f and a bottom half of g. The height is actually f minus g, right? So f of x minus g of x with respect to, and then delta x, right? So when I draw my rectangle, I want to note the orientation of the rectangle. If it's a vertical rectangle, which I'll call upper minus lower, and I need this for the rest of the chapter, okay? So I'm going to draw my rectangle and make sure the upper minus lower works. So notice all of my green rectangles, they all hit the top function at the height of at the very top of the rectangle, and they hit the bottom function at the base of the rectangle. If that doesn't happen, I cannot use the upper minus lower. So if I can draw the vertical, and it's kind of like, remember when you did the horizontal vertical line test, you kind of moved the line around to make sure that it only hit one place on the function. You're kind of doing that again with the single rectangle. You're drawing that single rectangle and you're doing a visual check that, okay, even if I moved it all the way through that area, would it always hit upper and lower, right? And if it does, it's good, okay? So why do I want upper minus lower? I want my area to be positive, okay? So I want the area to be positive. Delta x will always be positive. And if I use upper minus lower, I'm gonna keep things positive. And that's what I want every time, okay? And so this is going to be a theme. It's always going to be an upper minus lower or a right minus left. This particular set of functions works with both, and some will. And I like it when they work with both. I like it when they work with both because, right, I can ask you to do the integral twice and see if I get the same result every time. So now I'm drawing my rectangle this way. It looks like I might have a problem here, but let's just pretend I don't for now. If I draw my rectangle this way, and notice that the right-hand side hits purple and the left-hand side hits blue, right? If I draw my rectangle this way, and there's definitely an issue right here, but I'll draw a better one later. Then I'm talking about delta y. So I'm talking about C to D. I'm talking about, right, that my integral is really from C to D of f of x dx. Sorry. F of y dy, right? And so this is the sum of right minus left delta y. Chat. I got a chat. Let me see. Oh, Serrano's here. Good morning. You okay? It's no problem, Serrano. I just did a Simpson rule. I did one homework solution from homework 1, and then I just started recording for chapter 6. So you didn't miss much. This is only my second page. Yep, it happens. I don't want us stressing about, life is hard enough. Things happen. We gotta be okay with making mistakes and then just try and fix them as much as possible. It'd be nice to never make a mistake, but I don't know. It's not easy. As a human, I can tell you, it's not easy. So this one was from A to B of f of x dx. So it should be pretty clear when you're drawing a vertical rectangle or a horizontal rectangle, right? It'll be clear. So this one is clear, it works. This one's clear, it doesn't work, right? Do you see it? Where the issue is here? If my rectangle is really thin, do you see that rectangle there in black? You see it, both ends hit the purple curve? No good. I need the two ends to hit two different curves in order for me to calculate that width or that height, right? So this theme of upper minus lower is going to happen several times, or right minus left, in order to keep things positive. In order to figure out which way I'm oriented. Am I differentiating in terms of x's, or am I differentiating in terms of y's? Okay. So I think we're ready to do a couple problems. Now here's the deal with WebAssign and me. WebAssign makes easy setups and easy integrals. So most of your integrals turn into polynomials for WebAssign. And what I do is I make easy setups difficult integrals. So I want all of your integrals to turn into things from chapter 5. Otherwise, why the hell did I just do them? And WebAssign, I don't know why. It's too hard to make problems for WebAssign to do that. That's why. I mean, I spend hours I twist my mustache trying to figure out the perfect problem to give you, right? That will hit several aspects of what we've done. And then, you know, like I said, I can have one problem from area between curves turn into a partial fraction and a trig sub, right? That's my thought process. And then that way I get a chapter 6 checklist, I get a chapter 5-7 checklist, I get a chapter, right? You see what I mean? I'm trying to give you one problem and have you check off 3 of the things that we did in the semester, right? But WebAssign is valuable in that you're gonna get yourself to understand the geometry, okay, and then do a simple integral and find out if you got the answer right or not. Okay, great. And then what's going to happen on the test is you're going to now know the geometry, so set up the integral will be fine, but then the integral turns into a biparts or something like that, right? Does that make sense? So I just don't want anything to be a shock to you. So the WebAssign homework for this stuff is easy. Easy setup, easy integral. Mine, it will be easy setup, chapter 5 integral, right? So let's do some examples of this. Now there's a couple subtleties still coming, okay? When I have a delta x, it's just the universe we're used to, right? Function of x, no problem. When I have a delta y, now y is no longer my dependent variable. X is my dependent variable, right? So meaning I have to change all my functions to inverse functions, right? So that's probably the most difficult part about it. But if you practice enough, it will be very easy. So just want to do a couple of problems from the book right off the bat. Again, 6-1 should be very easy, but you need to have that kind of process written down, and you'll see where this right minus left and upper minus lower come in later on. So a nice simple one. Oh, there's a couple in here that are decent. So I like the problems here from 5 to 17. Actually, 1 to 17 is pretty good. And then from 33 to 39. So in MindTap, we got number 1 to 17. This is area between curves. And then number 33 to 39 is parametric. Parametric equations, which I'm going to review with you. They're not difficult at all. And Desmos will help us see it very well, too. So we'll be looking at that today. Sorry, examples. So this is no longer examples. This is MindTap problems, right? MindTap homework. So let's do... Let's do number 6. So I've got y equals ln of x. I've got y equals 4 over x. And I want the region from x equals 1 to x equals 3. So to sketch the region, right, draw your rectangle. And then find the area, right? So I know what ln of x looks like, right? And at 1 it hits 0, right? And I know what 4 over x looks like. Do I? Yeah. Why am I confused all of a sudden here? Let me draw a picture. Let me use Desmos. I'm confused for some reason. It's not the first time. I just, initially it doesn't seem right to me. But Desmos. So y equals ln of x. And I can restrict from 1 less than x less than 3. And xy equals 4 is what the one they gave me. That's what I was confused about. From 1 is less than x, which is less than 3. Ah, okay, clear. I was confused because I thought they intersected. That's why. So, but I don't like to rely on, pardon me, my memory for the graphs. I'd rather graph it, right? When I took Calc 1, I did it all on computers. So I had a computer in front of me in Calc 1, Calc 2, Calc 3. So clearly, I can see upper minus lower. So I'm going to get a nice little rough sketch of that here. Right? And so it's pretty clear that the area is here. And now, do you see that the horizontal rectangle does not work? I'll just draw one of them. You see that that one does not work. Because I want to hit 2 different curves. And while I could say I hit the curve x equals 3 and x equals 1, it won't work for this one. Now I hit the black curve on the right and x equals 1 on the left, so now I have to set up a different integral. I would like the one rectangle to work for the whole area if possible. So I'm going to do an upper minus lower here. And I can clearly see I have a delta x. So I want that the width of the rectangle, the base of the rectangle, parallel to the axis of the independent variable, right? Of the independent variable. So I'm differentiating in terms of x. So I'm doing the integral. How is this so far? Is it making any sense? It's not difficult, I don't think, right? I'm trying to be as clear as I can, I know. So we're doing the integral from 1 to 3 of upper minus lower, right? Which is what? 4 over x minus the ln of x dx. And all of these problems, just about all of these problems, will turn into two different integrals, right? I'll do a divide and conquer here. I'll do an integral for 4 over x and an integral for ln of x. And that allows me to give you one of them to be partial fractions and one of them to be trig sub, and et cetera, et cetera. So we're kind of off to the races here. I don't know if you remember the derivative of antiderivative of ln of x. It's x ln of x minus x. We did that by parts. So you're more than welcome to do it by parts again now and verify you get that same answer. But I'm just gonna go for it here. How we do? Anyone get there? Nice. Eleanor's there. Nice. Adam's there. Haoshin. Nice.
Can you explain the plus 2?
Yes. So first of all, I'm plugging in 3, right? So if I'm plugging in 3, I get the ln of 3 ln of 3 plus 3. So you should agree with this plus 3. And then when I plug in 1, right, I get 4 ln of 1. That goes away. Ln of 1 is 0. And then a minus. Remember the sign switch when I plug in the lower number. So plus 1 ln of 1, that's a 0 again. And then minus 1, right? And so 3 minus 1 is the 2. Name, is that clear? Is that what you were asking?
Yes. Thank you.
Yes, of course. So this one's not too bad in terms of WebAssign asking you to do something by parts, right? But it's one we've done many times, so it's pretty easy. So we'll do another. Anybody need a moment?
Can you do a one where we do left minus right?
Yep, right minus left. Yep, always right minus
Or right minus
Yep,
left, yes.
Yep. So sometimes they'll be hidden from you, and you won't know, right? So, like this is number 9. So this one's not that hidden from us. 6.1, number 9. I've got x equals 1 minus y squared, and x equals y squared minus 1. This one is pretty obvious that they're setting it up as x as the independent, right? So this is a function of y. So we're thinking delta y here, right? Or dy. But I don't want to just, completely trust that. I'm going to do it on Desmos, but I would like to show you at least a thought process for your TI-83. Is I could solve each of these for y, because that's what we're used to doing, right? So y squared equals 1 minus x. So y equals plus or minus square root of 1 minus x. And I get the positive root there from here, and I get the negative root there from here, right? So this is the positive square root of 1 minus x. Oh, I'm sorry. I'm drawing it the wrong way, aren't I? I need domain of 1 of everything less than 1, right? Yeah. So there's the positive, here's the negative square root of 1 minus x. So those I could graph easily on my TI-83. What's nice about Desmos, and so you're not going to have Desmos on the graph, but if it's something I think that only Desmos would give you the graph for correctly, I will give you the graph, right? So this was x equals 1 minus y squared, was it? X equals 1 minus y squared. Is that correct? Just remind me. Yeah. Hold on. And the other curve is x equals y squared minus 1. And so I think you can already tell where that's going to. So you can see for sure I need a right minus left, right? So let me get a decent picture here then, at least, right? So blue is this one and green is this one. And if I draw this particular rectangle here, you can see my upper minus lower doesn't work. I'm only hitting one function. I want to hit 2. So in the case that I think the graph would be very hard to get for you, I would give you the graph. If I thought the graph was very difficult for you to see or find on your own calculator, I would give you the graph. But it's pretty clear that I need this rectangle. Now it's also symmetrical, so I could do a little bit less work if I wanted to, right? I could just get the area on the right hand side and double it, right? Do you see that? I could just get the area on the right hand side and double it, and then I still have what I need, right? I would use this rectangle in that case. Right? I'd use that green rectangle. And so I'm hitting on the right curve, I'm hitting blue, and on the left hand side I'm hitting the axis. Right? So maybe we'll do both of those and make sure we get the same answer. Okay, so I know I need an integral from c to d. So where are these two things hitting each other, right? At what y values are they hitting each other? So it's pretty clear that 1 minus y squared equals y squared minus 1, right? And so 2 equals 2y squared. So y is plus or minus 1. So my integral is going from minus 1 to 1. Does that make sense? I know I'm doing a delta y integral, right? Because I'm a right minus left. So I need my integral to go from c to d, from the lowest y value to the highest y value. And then I need my right minus left. So I need 1 minus y squared minus y squared minus 1 to delta dy. How are we here? Make sure we're okay. Everyone's okay here? Charlie? Yes?
Yes.
You can kind of see that inside here, my parenthesis, I'm kind of getting something similar to what I had here, right? But I don't have to think about that. I get 2 minus 2y squared, right? You can see I get the same thing right there, right? 2 minus 2y squared equals 0 kind of thing. And now I'm integrating the terms of y. So I get 2y minus 2y cubed over 3. Evaluate at 1 and minus 1. Don't let me go too fast. You can see here why I'm saying the integrals on WebAssign are very easy. It's most of the time polynomials. Boring. And I'm just doing this stuff in my head, so. Now, what's nice about these problems in Chapter 6 is that you're going to know you're right. You can do them all on your calculator. So, but you want to show me your work and then double check on the calculator that you got it right. So I'm going to do this particular. Did anyone agree with my answer? Anyone get the same? Oh, I think I made a mistake, right? No, that's right.
How did you get that 1 in the beginning?
Because Robert's not too smart. Yes, now it's a 2, great. Thank you. 8/3? Did you get 8/3?
Yes, I got that.
Sorry, thank you. The more math you do, the harder it is to add and multiply. The higher abstract you go, the harder it is to do simple things. So let me do this one on the calculator. Does anybody need another minute before I do it on the calculator? And if you can do this with me, that would be helpful. So I've got my TI-83 here in a second. Let's see if I can find it. Oh, there it is. TI-84. A little hard to see this on the screen. I apologize about that. I make it as big as possible. But I'm hoping I set the integral up right? And the closer I and so I can do that to the original before I simplify anything, the better, right? So I had what I had 1 minus y squared minus 1. So I'm putting that in as 1 minus x squared minus parenthesis x squared minus 1. I can't change the variable on the TI-83, 84. I'd like to look at the graph of this and make sure that my bounds from -1 to 1 are visible. So I'm going to hit graph. Is everybody with me? So I got this function that I'm going to integrate. I'd like to look at the graph and make sure I can see from -1 to 1. And I can. Right? Everybody with me there? Anybody driving along with me? Just let me know who's doing this with me. Okay. Because, you know, I want you to make sure you slow me down or stop me if you need a minute. And I can go back and double check it. So I go to my y equal, I put my function in that I'm going to integrate. I look at the graph, I make sure I can see the bounds of my integral on the screen. If I can't, it won't do it for me. It's a pretty dumb machine. I like to call this thing a dinosaur. And then I go to calculate. And I go to calculate, I'm sorry, second calculate, right? And then you can see here in number 7, I have the integral. So I hit 7. And then it's asked me for my lower bound, that's -1, and I hit enter. And then my upper bound is 1, and I hit enter. And it will shade the region, and then give me my 2 and 2/3, right? Which is 8/3. Anybody need me to repeat any of that or see that again?
Can you do the area part one more time?
Yep.
Thank you.
Yep. So it might as well just do the whole thing, but that's okay. So here's the function. I put it in. Notice I could have put in my simplified function, but what if I made a mistake, right? So I put in my original function. I want to get a nice picture of the graph. When I originally see the graph, it won't have the area shaded. So I want to make sure I can see my bounds from -1 to 1. And then I'm going to second calculate and hitting 7. And then I'm saying, okay, -1 is my left bound, enter. My right bound is 1. It says lower limit, upper limit, right? Same idea. And it gives me that shaded area and 8/3. So I can know I get this question right on the test. Now, what the real issue is, okay? What the real issue is if you get it wrong, you don't freak out. So that's an issue, right? So you do the problem, you think you have it right, you go do all the work, get an answer, check it on your calculator, and it's wrong. So I have seen many students freak out at that moment and just lose it mentally. Oh my God, I got it wrong, I'm going to fail the class. Right? So you can really put yourself in a panic. You have to be conscious of that. If you got it wrong, you do a quick double check of both aspects, right? Maybe you typed something in wrong in the calculator. Maybe you just made a simple mistake setting up your integral. And then you leave it alone. You don't obsess about it. And I know that's not easy for some students to do, but I'm asking you. That's what our brain works. Like, say you're at a party with a bunch of friends and you're trying to think of this actor and you can't think of it. Oh my God, what's the actor's name? I can't think of it. You could cheat and use your phone. Don't do that, right? And you wake up in the middle of the night and go, Sidney Poitier. It just comes to us. So what I say is happening on the test is if you know you got something wrong, you can let it go and do something else. And then, so you've done that quick double check, can't find anything, because we can't. And then you start the problem over, completely over. And new piece of paper, don't even look at what you did, right? And then things get unlocked. That's the way the brain works. much like a computer does, kind of a defrag, where you're putting pieces back together without you knowing you're doing it. So nice. Let's look at one from an old midterm of mine, and then we'll take a little break, and then we'll do our parametrics. Okay. So, but you'll see this what I'm trying to build up here is this setting up the rectangle, because it's going to be real important when we do. I said I was going to do that one a second way. Let me do that. I could have seen that I could have done 2 times the integral from -1 to 1 of my blue function, 1 minus y squared minus, right, that other function, which was y equals what? What is this line? X equals what? Sorry, x equals 0, right? So I'm saying now I'm doing that red area. So I'm looking at that green rectangle. Right-hand side of the rectangle is x equals y squared minus 1. Left-hand side of the rectangle is x equals 0. Right? In fact, I could see symmetry top and bottom. Right? I can see symmetry top and bottom, so I could do 2 times the integral from 0 to 1 of 1 minus y squared. Right? So I see symmetry left and right. It's symmetrical left and right. It's also symmetrical top and bottom. So I can just get the one area in the corner here, right? I can just get this one area here and multiply it by 4. So that's what I'm doing here. So 4 times the integral from 0 to 1 of 1 minus y squared dy. And that's 4 times what? Y minus y cubed over 3. And all I have to do is evaluate at 1 now, right? So 4 times 1 minus 1/3. So 12 minus 4 over 3, 8/3 again. Same answer. So depending on who you had for Calc 1, they talked about all these symmetries, and you can cut, if you see something symmetric, you can just do half of the integral and double it. So, but I'm not making you do anything like that. Just sometimes it turns out to be a lot easier. All right, I want to grab a problem from a previous exam, okay? And we'll do this one, then we'll take a little break, and then we'll do parametrics. And so the good news is I won't do any of 6.2 today. So this is I'm really adding, the only thing I'm adding here is a setup, right minus left, upper minus lower. That's it, right? And you got a bunch of problems in MindTap. You have homework in WebAssign. I'm not giving Shawms for any of Chapter 6. But as we do Chapter 6, you can start to do midterms, right? How are we doing today? Anybody with me? How are we doing today? Is this feeling pretty easy, or what's going on?
It seems pretty straightforward right now.
It's not bad so far.
Nice. Thank you. Thank you for all those thumbs up. Either you're hitchhiking or you're with me. Yes, Adrian.
I'll be fine with time.
Yes. And precision, right? We want to be precise. We don't care about wasting paper, right? We're going to use as much paper as we want to, damn it. And then when I'm making $100,000 a year, I'll go plant a couple trees, right? Make up for it. So I'm just going to grab a problem from a previous semester. I'm going to do one from last summer. I tend to, in these problems, I tend to keep them in terms of x's. So, but you'll see when we do disk and washer method are perpendicular to the axis, and then shells are parallels. So if you and that's my little remembering thing. When I do a shell method, my rectangle's parallel to the axis of revolution. Otherwise, it's perpendicular. So you can see if I do one problem in both ways, I'd have to switch from x's to y's, right, or vice versa. How do I turn off my edit? I don't know how to turn off my edit. It's okay. Oh, I got it. Sorry, just give me a second. I'm opening that summer summer test 2. So if you want to beat me there, that's fine. Just give me a second here. I gotta open it. I hate when I move Blackboard to that Surface Pro. It's lame. Okay, so I'm almost there. Summer 2, test 2. Yeah, so here it is. So I've got it says use a trig. Yeah, you can see it. Yes, is that correct? So I've got it says use a trig sub and partial fractions to find the area of the region bounded by the following curves. It says do not convert your limits into thetas. So I'm saying go back to x's here, right? So don't turn it into thetas. Keep everything in terms of x. And so what I really have to do is figure out which curve is above and which curve is below. That's the most difficult thing, right? So I want to look at those on Desmos real quick. So the first one was y equals x over square root of x squared plus 1. Oops. And I can restrict the domain. What did I say, from 1 to 2? Is that right? Help me. From 1 to 2. I don't have to do this domain thing. I just really have to know which one is above, right? And the other function is y equals 5x minus 4. Someone tell me the other half of it when I get there. 5x minus 4. All divided.
Over.
Thank you. Yes.
Over 2x squared plus x minus 1.
Yeah. Oops. Shh. What did I do? What did I do, Robert? Okay. Y equals 5x. This is the hard part of the class. 5x minus 4 divided by 2x squared.
2x. Yes.
Go ahead. Keep going for me. 2x squared.
plus x minus 1.
And so clearly the purple is above, right? So it's an upper minus lower, right? And the first one is trig sub. And the second one is, oh, the first one's not a trig sub, is it? No, but I want you to do a trig sub. And the second one is partial fractions. So I don't have to do a trig sub on that one, right? So this is a summer 2020 test 2, number 1. I'm doing the integral from 1 to 2 of x over square root of x squared plus 1. I could do that as a u sub, right? But I'm asking for trigs. Minus 5x minus 4 over 2x squared. I forget it already. I know there's a 1 there.
Plus x.
Thank you. So there it is. So easy setup, right? Upper minus lower. Very simple. But now the trig, the work is going to take some bit of work, right? And I'm going to do 2 integrals. We're always going to divide and conquer here. So typically on these, I would work totally on one integral and then work on the other and then put them together at the end, right? So let's do the trig sub first, right? So I'm going to say this is star plus hashtag. It's my answer, right? So star is going to be the integral from 1 to 2 of x over square root of x squared plus 1. And so we need a triangle there. Who sees the hypotenuse already?
X squared plus 1.
Yep.
Or square root of x squared plus 1.
Exactly. And so that means I have a choice for my base or my height, and I would like to make my base, my height, x. This is going to be a 2 or 3 page problem, of course. Everybody okay with the setup? Nice. So x is tangent of theta.
Can't we do that with u subs?
Yes, but I'm asking for partial. I'm sorry, I'm asking for a trig sub.
Oh, okay.
So if I ask you for a trig sub, do the trig sub. Now what's nice is you could do it by partial and double check yourself, right? So dx is secant squared theta. And then what is square root? Oh, you could see I could just use this for the whole thing, right? Which is what sine. Yep.
Sine of theta?
Yep, yep. So I have the integral from x equals 1 to x equals 2 of sine theta times secant squared theta d theta. Make sure everyone's okay there. So I don't know if you remember me saying, what's my process now? Turn everything to sines and cosines and see what you have, right? So I don't know if you can see it, but I've got a sine of theta over cos of theta times another 1 over cos of theta, right? Which is really a secant tangent. And antiderivative of secant tangent is secant, right? Am I going too fast? I might be going too fast.
Yes.
Thank you. I'll slow down. Once I get my integral, my antiderivative, I'm going back to my triangle. And that's where I'm saying don't convert your bounds. Go back to x's. And secant here is simply 1 over square root of x squared plus 1. And I'm going to evaluate it 2 and 1. Let me know. Where are we here? Anyone okay? Now, I don't want to evaluate this yet. I want to do the other integral, piece them together, and then evaluate everything. So, and the reason behind that is because most likely I'm not going to ask you for the area. I'm going to ask you for an expression that gives the area. You know, a nice way to make sure you're right is to do the original integral in the calculator and then check what you get when you actually evaluate the integral and see if they match up. And I'll do that today. Can I move on to the partials? Anybody need more time on the trig sub? So I want to do my trig sub now, which I'm calling hashtag.
I have a question.
Yes, Charlie. Go ahead.
Sec theta equal to 1 over square root of x squared plus 1. And I feel like it was x squared plus 1. Square root of x squared plus 1.
Oh, you're right. Yeah, I got it upside down, right? Thank you. Someone else? Someone help me. Charlie, help me earlier. Okay, partial fractions. I got a factor, right? So I'm going to factor 2x squared plus x minus 1. So there's my factoring of that denominator. I just factored, you know, if I didn't see it, if I didn't know how to factor that, I could graph it and see that I hit a 0 of -1. or a 0 of 1/2, and then did synthetic division. But this is just a ax squared. This is a split the middle term factoring, right? So I want to set up 5x minus 4 over the 2x minus 1 times the x plus 1. Does anyone need help on that factoring?
Yeah, can you explain the splitting the middle?
Yeah, so we learned, like in algebra 2, if I have ax squared plus bx plus c, and I could find AC, right? And I would have, so F1 times F2 is AC, and F1 plus F2 is B. Then I could, and that's what I did. So I did 2 times 1 is -2, right? And so the factors of -2 are 2 and -1. They add up to +1, and they multiply to, oh wait. Did I make a mistake there? No, that's it. And so yeah, 2 minus 1 is 1x, right? 2x minus x is 1x. And then 2 times the -1 is the -2, the AC piece I got. And then I then I factor by grouping. I would imagine it's just not, it's been a while before you've seen that. Was that Eleanor asking about that?
Yeah, thank you.
You kind of remember that now, though?
Yeah.
Yeah. All right, so now we're on to find A and B here. Did she finally go out? Did she go out? My Surface Pro just quit. It's going, it's too much. I don't want to do it anymore. I got an A is -1 and a B is 3. Anybody else? Nice. So again, I'm just stopping there, just until you get there with me. Anybody there? Charlie, double check me. Thank you. Eleanor, you got there? Great. Anyone else there? Nice. Everyone's great. Nice, Charlene.
Professor?